Hello, welcome to the virtual conference. My name is David Golds and I'm a Program Manager in the File Systems group in the Windows Core OS group, obviously at Microsoft. I've been here about a year now, working with the File System team. I'm very lucky to be working with such a bright group of people. And really I'm here today to tell you what they've been doing in the file system since Windows NT 4. Well, in a word, the answer is lots. They've done lots and lots. The file system has been enriched massively compared to the NT4, and NT4 already had a very rich file system. NTFS is a fabulous base file system. I want to try and convey to you the magnitude of how much has changed in the file system. And really the best way I've found to do this is by means of an analogy. And really, I think of NT4 storage, NT4 file systems, as a sedan car. Really, the NT4 storage sedan has been great. It's had enough capacity so far. The layout could have been a little inflexible, but it served its purpose admirably. And now, pretty much everybody has one. But as your use increases, your demand increases. More people want to carry more stuff, and flexibility and convenience become more important. So really, moving forward to Windows 2000 is like a change from a sedan to a minivan. You get more space, you get more flexibility. You can easily rearrange the storage to accommodate your changing loads. But Windows 2000 is not your father's minivan. You get performance too. As you probably guessed by now from my accent, I'm actually from Europe, the UK in fact. And in Europe, there's a rather interesting minivan which better represents Windows 2000 file systems and Windows 2000 storage. This is a basic minivan initially, which was then grafted to a Formula 1 car chassis, racing car chassis, transmission and engine. This is a V10 200-mile-an-hour minivan, a minivan that goes from 0 to 125 miles an hour in 6.3 seconds. This is Windows 2000 storage and Windows 2000 file systems. If you look at this image, and this should be the image you take away of this presentation, burned into your mind, this is Windows 2000 storage. It's faster, it's more flexible, you're going to love it, and your users are going to love it. So to give you an overview of really what's changed and more importantly what hasn't, I'd like to present these items to you. Really, CDFS, the CD file system, and FAT are in a maintenance mode and have been unchanged really since NT4. We have added a new file system, the FAT32 file system. We've also added a UDF file system. But really, the focus of the enrichment, the focus of the new features is on the NTFS file system. And that's where we'll discuss most of this enhancement. This slide here shows you where each file system came in the versions. For example, FAT32 is new in Windows 2000. It's the first NT platform to have the FAT32 file system. I won't read line by line, it's there for your reference. Now, the new FAT32 file system is really just like the old FAT file system, but it's like an engine that's been bored out. Same basic design, just widened out to go bigger in this case. So the new FAT32 file system can be used to manage disk volumes of 2 GB and greater. Now, we actually limit the size of a new FAT32 file system you may create in Windows 2000 to 32 GB. The actual on-disk structure can go very large. In theory, it can go to 2 TB. However, on the Windows 2000 platform, there is a much better and more scalable file system available. That's the NTFS file system. So really, as a kind of sanity, we've constrained the size of a new FAT32 file system to 32 GB. If you do have a FAT32 file system created by, for example, Windows 98, which is larger than 32 GB, then you may still use that with Windows 2000. You can still read and write those files. We're only constraining the size of the volumes you create. Another new file system in Windows 2000 is the UDF file system, and this stands for the Universal Disk Format. This is really a file system for shiny disks, for CDs, for DVDs and the like, although its design blends itself as well for magneto-optical disks, worm disks, and really any of the new media types. You should see the CDFS being replaced progressively by the UDF file system. And for that reason, in Windows 2000, the UDF file system implementation is read-only. The standard actually allows both reading and writing, and in future versions of the operating system you will see UDF writing as well for media like DVD RAM, DVD plus RW, and MO disks. But for now, we're focused the UDF on CD and DVD media, and for very good reason. If you want to read DVD videos, you need to be able to read UDF file systems. This is the format for DVD disks. And since Windows 2000 has great DVD video support, you need a UDF file system. The UDF file system is standards-based. It's based on the ISO 13346 file system, which is the same as the ECMA 167 file system. But UDF really takes those standards and simplifies it. The ISO and UDF standards are very complex. There are many cases where even a simple choice like what character sets do I use for file names is given a huge number of options. In the UDF, you just simplify it. It says the format is Unicode. So really, UDF is described as a domain of the ISO 13346 file systems. When there are many options, reduces to one or just maybe two, and is much more implementable and interoperable. And you can get details of this standard on the OSTA website mentioned here. We will read UDF 1.02 and UDF 1.5 in Windows 2000. Windows 98 is able to read UDF 1.02. UDF 1.50 really gains you the ability to read packet-written CDRs. And Microsoft is committed to tracking the evolving UDF standard, and we're very active in the standards body. But as I mentioned before, the real meat of the change is in NTFS. NTFS was always a very sophisticated file system. It has a mechanism called journaling, which means that when you make a change to NTFS file system, it makes a log of the changes that are occurring. If the power fails, or the system is reset for some reason during complex write operations, when the system restarts, it can look at its log, recommit transactions that should have been committed, which did not get to disk because the write behind did not put it there, and similarly any disk files, any sets that got there but not being committed, will be undone. It's a sophisticated scheme. It gives a lot of robustness and reliability, and it really means that the file system has very high integrity. Now, in Windows 2000, there has been an on-disk format change. Because there are new features, and to simplify some of the coding and testing, we made a decision that Windows 2000 file system would not be readable by straightforward NT4 systems. The new features really did require the change. However, that said, the change should not really cause you any problems because of the following reasons. Firstly, the upgrade to the new format is done silently and quickly. The very first time any NTFS volume from NT4 or earlier is mounted. It takes just a few seconds per volume. It doesn't matter how many files are on the disk, the size of the volume, it's all down to a constant time operation. Second reason, that won't really have a big impact, is that we provide an updated NTFS driver in Service Pack 4. This has some limitations. There are certain kinds of new NTFS files, for example encrypted files, that NT4 does not have the infrastructure to read. However, any conventional files that only use NT4 features can be read in the system running NT4 Service Pack 4. The on-disk format change is really only going to affect systems that dual boot NT4 and Windows 2000, and clearly, if you have Service Pack 4, you can still access the files. The only other case to concern about is if you have removable media, for example MO disks, which are moving between machines which are NT4 and Windows 2000. Again, the procedure is very simple. Just ensure that any NT machines participating in this are running Service Pack 4. Note that there's no issue for network connections. If I have a Windows 2000 server and an NT4 client, the NT4 client can still access the files over the network protocols because the network abstracts the file system on this structure. Finally, my last bullet point on this slide, the Service Pack 4 NTFS.sys is really provided for evaluation and testing. The reason here really is that there's no upgraded check disk in NT4. So although you can dual boot, there will be limited check disk coverage in the NT4 dual boot scenario. It's really the check disk is there in NT5 in Windows 2000. And so for that reason we don't advise long-term use dual booting between machines. Another reason is it's a bit like taking that great Formula 1 minivan and putting the really cheap gasoline in it. You're not going to get the best out of it. There are a number of methods and techniques in Windows 2000 NTFS, for example the change journal and the quota system. That will be reset when you boot to Windows NT4 and come back to Windows 2000, and it will take time to rebuild the indexes. So really the reason you often dual boot is because you're either a developer who wants to use two platforms or a journalist who wants to use the two platforms on the same machine. But in most deployed situations you're really using one operating system, and of course the intention with Windows 2000 is it stays up. As you know, a great deal of work's been put in there at that focus. Windows 2000 NTFS, the first feature to mention is disk quotas. Customers have been asking for quota support for a long time in the file system, and it's here now in Windows 2000. It's a per user, per volume quota system, and it's based on the file ownership. You can either monitor or constrain the disk usage. So for example, I can set up quotas on a file system but not enforce them. So I can be informed of as an administrator, I can be informed of when those quotas get exceeded, and I can take action, nudging, gently telling people by email that they're exceeding quotas. Alternatively, you can constrain those quotas. You can actually require that if I have a quota for myself for 10 gigabytes, I can never use more than 10 gigabytes of the volume. And really, this comes to my last bullet point there, of what you see is what you get. When the disk quota is being constrained, then if I only have 10 gigabytes available to me, then I will only ever see 10 gigabytes. This differs from some other quota systems, where if there was 100 gigabytes on the volume, I might see 100 gigabytes free, but would get warnings on my screen when I reach 10 gigabytes. However, with Windows 2000, like I say, what you see is what you get. I would only actually be reported to me the 10 gigabytes of free space that was available in my quota. As I use an extra 2 gigabytes, I'll see 8 gigabytes remaining, not 98. And this is really good for administrators. It means that you won't get support calls from your users saying, why have I got constrained to 10 gigabytes, there's 90 gigabytes here? Because just because the space is there doesn't mean it's allotted to the user. There may be some more information coming in from a feed store, there may be a user with special requirements who's going to be putting a lot of data onto a system in a particular day. And so it's much easier and much more manageable to ensure that this quotas report what is available to a user. There are still APIs available so that certain applications can determine both the quota constrained free space and the actual free space on disk. But that's a new API which is not used by current applications. So current applications, and indeed any applications using the current free space calls, will continue to see the quota constrained free space. Now the disk quotas are accessed from a new quotas tab on the disk property page. This works both remotely and locally. You can see the page here on the right. And it allows you to put in a very simple default quota for all users. Or you can click on the quota entries button and put in a per user quota configuration. David can have 10 gigabytes, such and such can have 4 gigabytes, and so on. That quota entries button also allows you to go and see how much quota is being used by each of the users. There's also a very good programmatic interfaces. There's an iDisk quota COM interface described in the SDK. There's also a scripting interface available. If you look at the header files, you will find the details of that scripting interface. And this is very interesting because, as I mentioned before, this is a user-based quota system. It's not group-based. If you want group quotas, we do not enforce group quotas. However, the scripting interface gives you everything you need to do, everything you need in order to implement the tracking and reporting of group quotas. You can very easily write scripts that get information out of LDAP, the ADSI, and get information out of the quota system, and build tables of which groups are using quotas. And of course you can then run these and aggregate across machines as well. So it is actually possible to build a very sophisticated quota tracking and reporting engine on top of this base in-kernel engine. Similarly, the quota entry GUI has a very much drag and drop. You can select items, drag them to, for example, Excel to get reports in Excel. You can drag them to other volumes to transfer quota configurations to other volumes. A very rich drag and drop interface. And finally, the quota information is in the volume. There's no external database outside the volume. It's inside the volume. So for example, if you have a storage area network and you're moving a volume from one machine to another, the quota information is in the volume. Similarly, for cluster services, moving the volume across to another machine, the quota information is in the volume. And of course, it's also important for performance. The quota is not implemented as a filter on top of the file system, it's in the file system. And so, it's really the fastest path to manage and track this data. Another important feature, and we're coming back to one of these minivan analogies, is in my minivan, I can put chairs in, I can put chairs out, I can make the back big, I can make it a big van, I can make it a six-seater. And the really important difference between that and a sedan is I can do this at the point I need to do it. I don't have to pre-order my vehicle with a certain kind of load bay, or have a lot of time to reconfigure things. This is the analogy here for the file system. When I want to grow my volumes, I don't, in Windows 2000, have to take the data off, format, create a new volume, and put the data on. You can actually make changes to the volumes in place. So the behavior is increasingly online and non-stop in Windows 2000. For example, if I have an NTFS volume, a partition here, and a second partition after it, and I want to just grow that initial partition over the whole space, I can do that in Windows 2000 now, online. My users can be using the volume. It's a 100 gigabyte volume. I can online, with a disk administrator, grow the volume. It's a 200 gigabyte volume. Free space has been extended. And there are various hardware RAID manufacturers that allow you to actually extend the size of your LUNs. And then NTFS can dynamically grow into the space made available. Similarly, if you're using the software RAID support in Windows 2000, you can create, you can break, and you can recover your NTFS formatted stripes and mirrors without taking the volume offline. So I can start with a normal volume. I can decide that it's in use, it's very heavy. I'd really like that data to be mirrored in software. I can do that online. My users are not interrupted. All that's happened is that their data has become much safer because it's been mirrored, and they have no inconvenience, no downtime. If at a later date I decide that's not necessary anymore, I can return that to a conventional single volume. And then, for example, could change it to be a RAID 5 configuration to get some redundancy, but not necessarily at the same storage cost. Another feature, which is actually available on both app and NTFS, is you can actually force dismount even of open files. So, for example, if you want to do a forced check disk of a volume, even though people had file handles onto it, there is now a programmatic way of doing that. Checkdisk-f will do that directly, but also in the APIs and the SDK, a method is described for forced dismounting a dynamic volume, as long as you have administrator privilege. Another big area for the file system is the encrypted file support. This is not actually a new file system, but it's really a feature built on top of NTFS. NTFS provides a sophisticated encryption method which you can easily use for encrypting files. Now, an important part of the design is that every encrypted file is readable by one or more recovery agents. Now, by default, a recovery agent is the administrator, but this can be changed. For example, in certain kinds of organizations, there will be an information security division, and they will be the right people who have access to encrypted files. Alternatively, they might, in a smaller company, it may be the chief executive, or maybe the HR director, or in a retail organization, it's typically the finance department has access to the most sensitive data. The main point here is that you can choose whatever's appropriate for your business and for your organization. You can choose to have as a recovery agent, but there must be a recovery agent. And this is different to many other schemes where the encrypted data is really a black box. The user encrypts the data, the user has some kind of password to decrypt the data. But this has a whole host of management problems. These other designs, unlike EFS, have the problem of if you lose the password, you lose the data. Similarly, if on your file servers you have an encrypted file from some users, large amounts of encrypted files, it suddenly becomes a management problem. If you're a company that does standard sweeps of files on servers to look for appropriate information or inappropriate information, suddenly you come across a big chunk of encrypted data. If you're going to really follow through and find out what's in there, which you really will need to do if you're doing a sweep, then you suddenly have to approach the people, explain to them you need to inspect their data. It becomes a real management problem, involves their manager. It's just slow. However, with the EFS design, if the people who are doing the sweeps for appropriate data can use the recovery agent account, then they can actually check the data without interfering with any people or any business process. So the encrypted file system is very useful for both laptop scenarios. I have a laptop right here using to drive this presentation, and this laptop has a large amount of NT source code on it. Now, if this were to be taken in an airport, it could be very bad. I don't really want the NT source code to be left around in an airport. And so for that reason, the file system code on my machine is all encrypted, so that even if somebody does take away my machine, they can't access the data. And of course, Windows 2000 and Windows NT also has other mechanisms, for example, to delete the page file on shutdown, so that I know that even the page file is deleted when I shut down my machine. There's quite a lot of subtleties in the encrypted file system, and the best way to really understand them is to really understand how it works. Really, every file is encrypted with a unique file encryption key, the FEK, file encryption key. So it's not the case that every file is encrypted with my key. Every file is encrypted with a unique random key, a very random key. Then, this file encryption key, which is the key to the file, is then encrypted using the user's key. This chunk of data is now called the data decryption field. Similarly, that file encryption key is also encrypted using the recovery agent's key, and this is called the data recovery field. Same concept, different name. And this data decryption field and data recovery field are stored in a stream along with the file. The best analogy here is to imagine you have a key box. There is one key to unlocking the file. That key has been put in a box, and that box has multiple keys to it. The user's key and the recovery agent's key. In fact, there are APIs to enable you to have multiple users. There are programmatic ways of generating encryption groups, so that 3 or 4 individuals can have a common file accessible transparently by them, but by nobody else, other than the recovery agents. There's no user interface in Windows 2000 to support that mode, but the APIs are there and supported to do it. So, to understand this, you really see that it's not a key escrow scheme. At no point did the recovery agent have access to my keys. There's a level of indirection here, which ensured that my keys were always my keys, and nobody ever had them. One final point on EFS is that you cannot encrypt and compress a file. You choose one or the other, encrypt or compress. There's a few reasons for this. The main reason is that at the time of development, the cost of making these two to work together exceeded the benefits we saw from putting them together. This may change in the future, but for now, encryption and compression is difficult for a number of reasons. It makes backup more complicated. It makes the ordering of code much more subtle. For example, encrypted data is less compressible. And so this may return in a later version of Windows NT, in Windows 2000 or whatever its subsequent versions are called. But really the key here is that you can't currently encrypt and compress files. Another point, going back to flexibility, are volume mount points. Windows and DOS have always had the 26 driver letter limit. You always have A:, B:, C: for your file systems. Windows 2000 is the first to really break away from this with a mechanism we call the mount point. The mount points really mean that you can now mount a volume, in other words a file system, to a directory, a drive letter, or even both, or even several locations. The directory you mount it onto must be an NTFS volume. You cannot mount file systems onto a fat volume, as a fundamental mechanism beneath which is required is only supported in NTFS. That is called a repass point. However, you can mount any kind of local file system on top of the repass point. So if I have an NTFS file system on C:, I can mount a local NTFS volume into that. Let's say C:/data. I can mount a CD drive into that namespace. I can mount a FAT file system into that namespace, all transparently. I cannot mount in a remote file system. In Windows 2000 Beta 1, there was actually a method for mounting a remote file system into the mount points, but that raises many security issues. So we changed that to just have local file systems mounted on this mount point. But mount points are very smart. We use effectively a grid on the volume to build the association between the volume and its preferred location on the machine. If I add a volume to my machine and choose to mount it at D:/data, I take it away, and then later I bring it back. If I mount at D:/data, there's a certain stickiness to the location. However, if in the meantime I had to put another D:/data and then bring back the original, it will understand you can't have a conflict, and it will mount it in a default other location. So volume mount points are actually very sophisticated. It comes back to this point about flexibility. If I have a file server, I want to add more space to a certain directory, I can do that. I can just put in a new volume as a directory. For example, if I have a sal/1999 directory that's full on the volume, I may decide that for my sal/2000 directory, I just put in a new volume at that directory. And of course, there's this issue with storage classes. Since these are different volumes, they have different storage properties. For example, I could have on a server a single D: drive letter, which is an NTFS volume. I could mount into that a file system called D:/database, which is mirrored, a good configuration for databases. I could have another directory called documents, which is actually a RAID 5 volume, which is a good configuration for document directories. I could have a temp directory, which is striped, to give me an extra performance for those temporary areas. And this would not be a sudden overflow of drive letters confusing users. It would just be a very natural temporary database documents directories, which the administrator set up to have appropriate storage classes. And of course, if you remember that these can be changed dynamically, then you get a great deal of flexibility in how you configure. And of course, this is another way to get better granularity on your quota systems. Our quota system built in is per volume, but now that doesn't mean per drive letter. Another feature in Windows 2000, a very small one, but one which people I think will really appreciate, is the amount of emphasis we've placed on check disk. Volumes are getting very big, very fast. We are seeing terabyte file servers, lots and lots of data on servers. And check disk runs very rarely on NTFS. The journaling scheme in Windows 2000 and Windows NTFS really ensures that data is typically consistent, even if power fails at a critical moment. However, there are a range of edge conditions which will provoke a check disk. Or, of course, the administrator can require a check disk just out of a procedural safety requirement. And in Windows 2000, the key here is that check disk is faster, and it's more scalable for large directories. As your number of files in your file system grows, check disk time generally increases. In Windows 2000, the algorithms are much more sophisticated and scale much better. We've also worked on making the progress indicators more accurate. There was definitely a kind of slow, quick, slow approach in Windows NT4 check disk. Also, focus has been placed on check disk to make sure it's really very scalable and very user-friendly in this progress. We've also done some work on the text. There was some of the language was a little disturbing, and so we made sure that it actually means what it means now. Some of the phrases like fixing corruption in directories just meant it was relinking directories. It had the information, it was just relinking the information appropriately. Again, a developer's idea of corruption of a data structure might actually mean that there's any data actually at risk, just mean that it was not as it should be, but there was redundant information to ensure that it could be relinked. So, checklist now is giving much friendlier messages, much more appropriate to what it's actually doing. But really, you want to know about the performance. So I'll give you an anecdote. It really does change a lot on your kinds of hardware, your kinds of RAID controllers, or your kinds of sizes and distributions of files. But on a typical volume that we tried, a 45 gigabyte volume with 2 million files at around 85% capacity, check disk on that system was reduced from 33 hours with NT4 to 100 minutes with Windows 2000. And I will emphasize your mileage may vary, but generally the feedback we've got is that the performance is really excellent. A really excellent enhancement in Windows 2000. Another feature in the box now is defragmentation. Defragmentation utilities have been available for Windows NT for quite some time now. And one thing to understand is that certainly since NT4, in most cases, the engine that's doing the defragmentation is actually the file system. NT actually supports APIs where the file system will offer to rearrange the file. In a system like Windows 98, generally a driver is making changes directly on the disk when appropriate to do so. NT is a more sophisticated, multi-threading, more complex environment, and so it's appropriate for us to export APIs to allow defrag utilities to defragment the volume. So in a sense, defrag has been in NT since NT4. What's been missing is the policy agent and the utility driving that engine. And now we have such an engine in Windows 2000. It's provided by Executive Software, the well-known providers of the disk keeper utilities. It's an MMC-based GUI, but it is just a base implementation. It only defragments local volumes. It's manual operation. There's no scheduling. And there's still value in ISV enhanced versions of defrag. The defrag operates on all the writable Windows 2000 file systems. And also, the actual defrag APIs have been enhanced in Windows 2000. So there's a richer and improved granularity of what to defrag. An important feature of performance in a system is to make your IOs go faster. You shave seconds off here, you shave microseconds off here to make the system go faster. But really, a good lesson from databases is the idea of query optimization. The best I/O in terms of performance is the one you don't do. And really, the change journal is a way in the NT-based file system in Windows 2000 to remove a whole large class of I/O operations. So think of this as a query optimization for file systems. The change journal is actually a volume-wide change log. It's a log file which describes the nature of changes to the file system. It has entries such as, this file was deleted, this file was renamed, this file was appended to, this file was encrypted, this file was decrypted. And this log grows to a certain size and then starts to reuse space. It doesn't just continue occupying space, it just occupies the configured space on the volume. By default that's 4 megabytes, but utilities and APIs are available to increase that. And the change journal can be as large as half the volume. The changes are tracked on a per file basis, and we actually use this change journal in a number of applications ourselves. A good example is the Microsoft indexing service. Windows 2000, all the product units from Workstation, Server, Advanced Server, Data Center, all include the indexing service. And this is the best way to think of this is web search for your system. Web search brought to your system. It's kind of embarrassing sometimes to think that it's easier to find a document outside of on the World Wide Web than it is to find it in your own system. And the reason is you haven't necessarily got an indexing service running. Well, now there's no excuse. Windows 2000 has a very excellent, well-integrated indexing service. And one of the reasons it gets excellent performance is it uses the change journal. It uses the change journal to understand what to index. There are certain kinds of application, like an indexing application, which need to understand what has changed on a volume. And these applications generally will do a scan of the volume. Let's go back to my example of 2 million files on a volume. If an indexing service or a virus checker or some utility is waking up, doing a scan of 2 million files to look for their change times, that's a lot of I/O. Especially if I'd only actually changed 10 files since the last scan. Really, I think it would be much more sensible if it just knew psychically what to index. And really, Change Journal is the indexing service's psychic friend. The Change Journal will tell the indexing service exactly what has changed since a point in time. And of course, there is the possibility that the Change Journal overflowed, that between the last scan and the new scan, records have been missed. And so there will always be cases where an indexing service or some utility will have to back down to a full scan. But the Change Journal records are very small, typically 80 bytes per record, and if you write multiple times to the same file, it will not write multiple records to the journal. So when you consider that this is 4 megabytes by default, configurable to larger sizes, in most cases you will find that all the changes since the utility last scanned are available in the Change Journal. And so that kind of peak you get when a scanning operation is going on for indexing, for virus scanning, even for backup for the last recently used files, recently changed files, that information is all available in the Change Journal. And so the Change Journal is removing a whole class of IOs. So I like to bring back my slide. I like to bring back my Formula 1 minivan and to really point out that there are lots of ways you can get performance. There's obviously been lots of tuning and performance in Windows 2000, but also there's lots of really big enhancements in various areas. Indexing service and the Change Journal are very good areas where operations like I want to find this data on this file server would previously have invoked lots of server load, and now with the indexing service and the Change Journal is a very light load. Another feature kind of under the hood in Windows 2000 is sparse files. This is really a file which has unallocated gaps in. I can have a file which is marked sparse. There may be a megabyte at the beginning written, a very large gap, and a megabyte at the end. Now, this isn't going to seem very useful immediately to users, but for developers it enables various interesting applications. There are sparse array implementations. There are methods for writing dynamically sized queues and logs. You can have a log file that increases in size, and rather than wrapping around to the beginning and having a rewriting the space in place, you can just have the file apparently grow and make it sparse behind. That's actually how the Windows 2000 Change Journal is implemented. As the Change Journal increases, rather than going back and writing records at the beginning of the file, it just increases and makes sparse behind. This is also used, for example, in the HSM system in Windows 2000, and it can be used in a whole range of applications. For example, even the indexing service takes advantage of this mechanism to implement more efficient algorithms. Another feature in Windows 2000, very much under the hood in the file system, is the idea of an object ID. This is really a programmatic way of assigning a GUID with a file. So if a file later gets renamed or copied across systems, that GUID remains constant. Now we actually use this in two services in Windows 2000. One is the link tracking service. If you've ever made a shortcut in NT4 and later you've gone to find it and the file is moved, obviously there's the utility which will actually try and find the file by looking for the name and attributes the same on local file systems. However, Windows 2000 has a much more sophisticated approach. There's actually a link tracking service, so that when a file with an object ID is moved to another local file system or to a remote NTFS file system, those shortcut links can still be resolved. So that means if I make a link shortcut on my desktop to a file on an NTFS volume and subsequently move or rename that volume locally or to a remote NTFS file system, then I can still actually resolve that shortcut. When I click on the shortcut, I'll find the correct file. Similarly, if I have an OLE document and I made a link in my word processor document to a spreadsheet document, then I will still be able to resolve that spreadsheet document, even if it's moved across the system. And the mechanism underlying this is the object ID. Another service using the object IDs is the file replication service, which is part of the distributed file system. The object IDs here are used to give absolute identifier of a file, so that even through complex rename operations, which would be hard to track otherwise, the file replication service can do the right thing and replicate the right file. Windows 2000 also has a feature called bulk backlog checking. Again, very much under the hood, but it's an important performance benefit for certain class applications. I think the key target here really is the index server. It's a way of checking a user's security ID against multiple files. If you have 100 files, and rather than open each in turn to get the access denied or status OK for the open, I can just say, here are 100 files, tell me which of these I can open. This is using the indexing service. When I make a query to an indexing server, I might make a query which is David Gold's fired incompetence. See those 4 words in a document. Now, if I got back from the indexing service that there was one hit, and I couldn't read the file, I'd have a pretty good idea of what was going on, even though I didn't have the actual file itself. So clearly the indexing service has to mask out hits on files I have no access to. Now, if I'd been really nasty and put on 100 files with those words in on the server, then I could just tell that in fact there's 101, one more than I expected, or any more than I expected, that there were other documents with the same theme in them. So it is important for a secure indexing service to check that I have access to all the files in the hits, and it can be a long time. I can be really looking through hundreds of files to see if there's just one more than I expect. I'm looking for a particular sentence. And so the bulk backlog checking is used by the indexing service to very, very quickly check of these hits the user has access to, which thing to see is that can he actually should be reported to him. And so the bulk backlog checking is an excellent method for doing that. Another optimization is this new API for finding files by owner. So for example, a quota tool may wish to list the users of a file, files owned by a user. The best way here is to use this API, and the file system will actually look through very efficiently for the files owned by that user. This is much faster than, in comparison, walking through the tree of files on the file system to get to that list. If there are 2 million files in the volume and I only own 2, this API will do it in roughly 2 operations. If you had 2 million files and you didn't have this API, you'd have to use 2 million I/O operations. Significant difference. Again, a kind of query optimization for the file system. Now, there's a great deal more information available on the file systems. At the TechNet website, there's more information, and there are some white papers on the Microsoft.com website. There's the Enterprise Class Storage in Windows 2000, which talks about the file system features, and as well the wider storage features, including the hierarchical storage management, backup, distributed file system, client-side caching. When I said that storage has been enhanced in Windows 2000, I wasn't kidding. There's lots of really good, important stuff in there. If you want to understand the encrypting file system in more detail, it's an excellent white paper on the same website describing how that works and how to manage it. So when you come to deploy, there's some key questions you should ask yourself. And a really good one to start with is, do I still need a fat volume? There's been a very common practice in sites to have a Windows NT system with a fat volume for recovery, and then the data volumes on NTFS. Now, NTFS is a far more recoverable file system. This journaling design I mentioned before really does mean that it is a very robust, safe file system, very good data integrity, even if you pull the plug when there's lots of complex change going on in the file system. So really, NTFS is the place to have as your system volume. Perhaps people still want a fat volume so they can boot a DOS floppy and go in, delete files, stop drivers, so that if they have a rogue driver that is preventing the system booting up, they can delete it and continue. Well, there's now 3 good mechanisms in Windows 2000 to make that unnecessary. For a start, there is the recovery console. After you've installed your system, you run Win2032/cmdcons, then that will install a recovery console, a very small console you can boot into, which will allow you to access the system files, allow you to take files off the system, delete files, and make certain registry changes. A very safe, reliable recovery console that will do most of the things you were doing in your DOS boots. There's also a safe mode boot, which will only load a minimum subset of drivers, and that will typically get you running. Finally, there is a last known good, which has always been there in NT4 as well, but there have been a number of enhancements in Windows 2000. If you found it didn't suit you in NT4, you should look again in Windows 2000 to see if the improvements have overcome your concerns. So I think the answer to that question is no. You don't still need a fat volume. You really should be going NTFS. The recovery's there. NTFS has always been excellent for robustness and stability, and it's a really good time to make sure your systems are now fat-free. You should consider using volume RAM points. They're a great way to get dynamic flexibility in your system. The ability to add and remove storage, move it around, rearrange it. If you have large points of data, rather than making them just part of a big volume, consider making them an individual file system. You'll get better scalability under performance, and you'll get better granularity for checkdisk and other operations should they occur. And of course, you'll have more opportunity to move more volumes in the system later. You should also really consider the encrypted file system. It's a very easy to use feature. It requires no configuration. It does require Active Directory for the recovery agent system, but get your users with laptops in the habit of using the encrypted files to make sure that the data you take on the road is really secure as it should be. There's always the classic security testament that physical security is the only real security, but in reality with mobile devices you can't always guarantee that laptops and devices are very scalable, and it's easy for somebody to target a device and take it. So the encrypted file system gives you excellent safety for laptop configurations and also in sensitive documents and information inside an organization. A point about performance tuning. An important performance element is the log file size. Now, Windows 2000 actually configures a larger log file size, and here I'm talking about the logging used by the journaling file system. When the log file is full, NTFS is forced to do a quite expensive flush of the log file, and these will be a noticeable hiccup in performance. If the log is appropriately sized, this will not occur, and so if you increase the log file to approximately 64 megabytes, then you're very unlikely to have your log file full events. Now, by default, Windows 2000 will be coming with larger log files, but you can use checkdisk/L to ensure that you have a log file size you require. Another issue of tuning is really the allocation unit size. Most volumes you'll create will have 4K allocation units, but if you want to create a smaller volume, you may still wish to explicitly create a larger allocation unit. And this really makes sure that the file is will have less tendency to fragment. You should be aware that if you format a volume with larger than 4K clusters, then you will not be able to defragment or compress that volume. So really, 4K is the optimum cluster size for NTFS. Another important point to mention is that for the first time, Windows 2000 setup creates native NTFS volumes. NT4 and all its predecessors were creating fat volumes and then converting them to NTFS. And this tends to lead to a more fragmented volume. Windows 2000 creates a native NTFS volume at setup. So a lot of customers who have reported that and been concerned about that in the past were pleased to see that. And finally, defragmentation. The real key of defragmentation is to fragment early, fragment often. If you get your system very, very full, it becomes very hard to defragment the volume. Really, it's a very good preventative measure to make sure that performance stays as high as it can be. And that brings me to the end of my presentation today. I hope you found it enjoyable. I hope you find there's more information available from TechNet and NT Server. And I hope you enjoy using the Windows 2000 file system.